Okay, this is your non-technology savvy teacher trying to be technology savvy for your benefit. So at this point you should know that kinetic energy is the energy of motion. Potential energy has to do with mass and the height above the zero potential energy level. In order to change kinetic energy, we can apply a force over a distance, which is work. So when we do work on an object, we change its kinetic energy. Therefore, we can set those two quantities equal to each other, and I'm going to try to solve this problem, which is number 1 on your worksheet. So when you get this, the tops of the towers of the Golden Gate Bridge in San Francisco are 227 meters above the water. So a picture is not a bad thing. This height then is 227 meters. A worker drops a wrench from the top of the tower. So here is the wrench with a mass of 655 grams. Right away I know I don't like grams. Everything we've done, grams need to go to kilograms, so 0.655 kilograms. Right now, just stopping there, what type of energy does this wrench have? You should know this answer is potential energy only. It's at rest at a height above the zero level. Okay? If the average force of air resistance is 2.2% of the force of free fall, what will the kinetic energy of the wrench be when it hits the water? So here we have the water. When it hits, it's only going to have kinetic energy, and the question is, how much? Because they say that there is air resistance here, is the potential energy at the top going to be equal to the kinetic energy at the bottom? The answer to that is no, because some of that energy is going to be transferred to friction due to the air resistance as it is falling. So if I look at the wrench, let's say midway, what are the forces acting on the wrench? Forces down from gravity, so here's the weight force, and there's a resistance force from the air that is there. These two vectors are totally not to scale because in the problem it did say that the air resistance is only 2.2% of the force of free fall. Therefore, this resistance vector should be much, much smaller in magnitude than this weight force. But because I'm trying to do this on the screen here and it's very difficult to draw it to scale, we're going to just work with our numbers. So can I find either of these forces? Yes, I can find the weight force. Weight force is dependent on mass and gravity only, and so the mass here was 0.655 kilograms, and gravity is 9.81 meters per second squared, and so you get 6.42555 newtons is the weight force. Do not round this answer because it's not your final answer. In the problem then it said that the force of the air resistance was 2.2% of the force of free fall. So I can say, okay, the air resistance then must be 0.022 times what I just got from my weight force, 6.42555 newtons, and I get an air resistance force of 0.141361. Because we are doing work, the air resistance is doing work on this wrench, the weight or gravity is doing work on this wrench, we are going to try to find the net work done on this wrench. Well, we know that work is force times distance. Each of these forces is doing work, so I could solve for the work that the air resistance does, the work that the weight force does, and then get the net work. Or I could get the net force first, then solve for work. I'm going to get the net force first. So the net force acting on this wrench is the difference between these two, because the weight force is down and the air resistance is up, so the difference between the two will give me the net force, and that difference is 6.284 newtons. And the direction is down for the net force because the weight force is so much greater than that air resistance force. So if I want to find the work done on the wrench, we have the net work done on the wrench is going to change the wrench's kinetic energy. Remember, we said at the top it was only potential energy. At the bottom it's going to be only kinetic. These two things are not going to be equal, though, because there is work being done on the wrench that is going to change its kinetic energy. Okay? So the formula for the work is the net force times the displacement in the same dimension that the force is being applied. Anytime we have change in, that means the final situation minus the initial situation. I know the net force is 6.284. I know the displacement is 227. I do not know the final kinetic energy. That's what I want to know. But I do know the initial kinetic energy is 0. So the final kinetic energy is going to be equal to the net force being applied to the wrench over the displacement that force is applied, and we will get a final kinetic energy of 1,430 joules.